All right, let's take a look at problem 12 here. It says, which of the following series converges for all real numbers x? So I used kind of a combo of process of elimination and then falling back on enforcing the condition of convergence of ratio test type stuff. So first of all, I looked at A, B, and C, and they were all so similar, right? They all have x to the n for the top, for the numerator, for defining the terms. And then on the bottom, you've got n squared, and square root of n. And since the directions are implying that only one works, for me, I decided that these terms would go to 0 faster than the 1 over n and the 1 over the square root of n. And for that reason, I decided to eliminate A and C. And then what I did was I enforced the condition of convergence of the ratio test on B. So I'll just say, like, I'm considering B right now. So I did limit as n approaches infinity, and then a sub n plus 1 would be divided by a sub n, and then I'd want that to be less than 1, and then cancel stuff down. Oh, that's about it for that. Anyway, and then yeah, as far as this limit is concerned, absolute value of x is a constant. And then we basically have n over n plus 1. Well, either way, it doesn't really matter. So this limit would equal 1. Think about degree 2, leading coefficient type thing with horizontal asymptotes. And so you'd be left with just this. And then the solution to this would not be all real numbers, right? Like the solution to this would be x values from -1 to 1, right? And then if we were, you know, I just ruled this out. If we were asked to find the interval of convergence, I'd have to check in points, but I wasn't asked that. So I just ruled B out because the solution to this is not all real numbers. Okay. And then up to you how hard you want to think, but I was just kind of going down the row. And so the next one I would check doing this type of work was D, which does end up being the answer. You can see I've got it highlighted there, but even if I didn't know that, you know, I could have just gone down the row and, you know, and done forcing condition of convergence of the ratio test type stuff. So I'd have e to the n plus 1 times x to the n plus 1 over n plus 1 factorial multiplied by n factorial over e to the n, x to the n, and that has to be less than 1 if it's going to converge. And then cancel it down. Next, you can factor out anything that's constant as far as the limit is concerned, and so that would be basically that. You'd be left with the limit as n approaches infinity of the absolute value of 1 over n plus 1. And then from here, you know, what does this limit equal? Well, it equals 0. And so if you write it in, so the absolute value of x times e times 0 has to be less than 1. You know, I hope you could see if you write it like this, that x could be anything, because no matter what this part equals, you're going to be multiplying it by 0, so it's going to be less than 1. And so your x value could be anything from negative infinity to infinity, and boom, we found it. It's option D. So I hope that makes sense. I think I'm going to go ahead and do problem 13 in the same video here. So the integral from 1 to e of x squared plus 1 over x with respect to x. Please always be on the lookout for improper fractions. And so that means that the degree of the numerator is either the same as the degree of the denominator or it's bigger. In this case, it's bigger. And be prepared to do what it takes to write your improper fraction in mixed fraction form. And so for this problem, I would just divide the x in. So x squared over x is x, and then plus 1 over x dx, like so. And then just antiderivative that thing. So let's see, we'd have antiderivative of x is x squared over 2 The antiderivative of 1 over x would be the natural log of the absolute value of x. And then we're going from 1 to e. So let's plug in your upper bound. So you'd have e squared over 2 plus the natural log of the absolute value of e, which is just e. And then we're going to plug in the 1 and subtract the results. So we'd have 1/2 plus the natural log of the absolute value of 1, which is just 1. And then let's just evaluate what we can. So I'd have e squared over 2. Natural log of e is just 1. Minus 1/2, and the natural log of 1 is 0. And so there you go. So I don't know, let's simplify it. E squared over 2, 1 minus 1/2 is 1/2. And then that would simplify out to be option B here.